Good afternoon, ladies and gentlemen. I'm Kochu, the project manager for UMP Private Limited. I'll be sharing our challenge statement on behalf of UMP. Firstly, a short introduction here. We are a lubricant manufacturer based in Singapore, Jurong Island. A few examples of our products are automotive, marine, industrial lubricants, and refined glycerin. The services we provide are tolling, blending, contract manufacturing. Due to our nature of business, we know that the waste stream generated in our industry are very harmful towards the environment, and they are usually sent for incineration. After incineration, the remaining waste, such as sludge and solid residue, will be sent to landfill. Basically, it's a series of pollution to our environment. Hence, we have decided to come up with a sustainable goal to reduce the waste stream from our industry that are sent to incineration by 50% by 2030, and to promote the culture of re-refine and reuse. We know that if we can separate the various components from the waste and re-refine them, they will be as good as new and will be reusable. This will help to reduce the pollution generated from the incineration significantly and possibly presenting new business opportunities. As such, UMP are venturing into re-refining and separation of waste for reuse. Currently, we are working with BASF Singapore in coming up with innovative and sustainable separation techniques for their waste stream. A short introduction of BASF. They are the world's leading chemical company, and they focuses on combining economic success with environmental protection and social responsibility. The waste stream we got from BASF is comparable fuel. We have managed to identify a number of variable materials from the comparable fuels which can be reused. The materials are mainly methanol, methylox, triester, and etc. Currently, we are focusing on these three materials as they make up the highest percentage in the waste and can be reused in our industry. We have the facility to recover back the methanol to 99.9% purity from the comparable fuel. Internally, we have performed lab trials to recover the methanol, and this is a short video on the lab trial for reference. Through the lab trial, we have managed to recover 99.9% purity of methanol. And in our process, we are planning to recover the methanol through a solvent recovery unit, which consists of reboiler, condenser, stripping, and rectification sections. And we are confident that this is achievable. So here's the challenge. After the recovery of the methanol, we are left with a large volume of highly viscous chemical residue, which contains the variable materials, which we are having difficulties to recover as of now. Since we are not able to further separate the waste, we are just having back the usual option, which is to send the large amount of remaining waste for incineration, but that will be going against our BASF sustainable goal, further polluting the environment, and from business standpoint, it will not be cost effective. We have the facility for reprocessing and the knowledge of the value of the waste materials and the expertise in these areas, but we are lacking in the innovative and sustainable separation techniques for different types of waste. So what we are hoping to look for here is to find an innovative, sustainable separation solution to separate the materials in the waste so we can take a step forward with our goals. At the start, we will be focusing on what we have on hand, which is the waste stream from BASF, and what we hope to achieve at the end is to recover the material from the waste residue. The materials will be prioritizing methylox and triester. Recovered materials should meet the specification required to be reused. At this moment, I'm not able to provide the specification we need. Treatment and recovery process should be operated in batch process with minimum manpower requirements, preferably through automations. Once we manage to resolve this challenge, we will be able to dive deeper and conduct more R&D into other innovative and sustainable separation techniques that can be used for other waste. That will be all from me. Thank you.